Oh, my timer is going? Okay, so, all right, so let me get, okay. So we do have a slide coming up here. Okay, so today we want to talk about a topic that we've introduced before. It's this topic of health chain management. It's the topic of how we get better at transposing those 20 years of knowledge that folks like Seagate and WD have in understanding failures on hard drives into something that becomes immediately actionable within the data center. So it's the work of understanding it's the work of not having to collect all that smart data, not having it to email it back to the firmware engineers in Longmont, wherever. It's the work of they have within reasonable means, they have packaged up some of their own internal test cases, and they have delivered a library to Apple so that we can immediately make a decision on whether a drive is good or bad. Now, this is not, from our perspective, this is statistically accurate. This is not something that you can run at the enterprise level, but it's something, if you're running across millions and hundreds of thousands of drives, more often than not, Seagate, WD, the Toshibas and Microns and all these guys, they get it right. Okay?
Which one is
and
forward?
the ability to get it right, what that gives us is then the ability to implement a whole bunch of other software around the ecosystem in a lot more simplified and a lot easier way to actually handle. So we made good progress. I think it's been about a year and a half since we went to OCP and said, let's try and build this library. Let's move away from that whole world of smart. Smart just, and that's sort of the data, it doesn't scale. And I know there's been sort of a similar trend within the NVMe world and sort of that concept of a health variable. But, hard drives are going to be with us for a long, long time. I mean, there's, it's not, so we need some good tools, some good mechanisms to quickly make that decision in the data center to see if you are good or bad and you should continue into production. And that simple binary answer of being able to say it's good or bad within a statistical model, what that then allows us to do is to build more simplified software with regard to how we manage returns, how we transpose information back to firmware teams. I don't know if there's any firmware engineers in the room, but if you've ever worked an issue or you ever worked a bug, and your debug data is smart, yeah, you're going to struggle. So within the library, there's the concept of let's protect the vendor's IP, and then let's give the firmware engineers a better path to export a whole vast array of error codes that have meaning within their product and that can then allow them to quickly and more accurately diagnose problems. But I was only given one slide. So my slide was...
Thank you, Stephen, for giving us this introduction, right? So basically, today we are going to talk about the health chain management. This is an update for the group. So for many of you guys, you have been involved in the previous discussion on the health chain management. So Stephen pointed out why we are here, why we want to do this project, right? So today I also have Naman from Apple to join me to talk about their use case. I will do the quick... Yeah, my name is Jun. I'm from Seagate. I'm the cloud architect working on the planning and the strategy team. So the whole point, like Stephen was describing, right? So the whole point is we want to put your the vendor failure analysis team, your vendor reliability team, and the operation team into one box, which is the health chain management library. So back to last year, it's about this time. So we had a talk in the OCP platform, right? So we talk about this idea. So today, after 1 year's hard work, we want to quickly go through what we have done during the last year. And Apple will help us to share a use case, how they picture this library can help their data center operation. And then we want to talk about what we want to do in the future quickly. At the very end, without all the vendors and our customers to join us, we won't get a very successful project. So that's why we say we want to call the action for this project. Well, for many of you probably already know this. We just want to quickly review what this project is about, right? So we say this is a user space library. This has nothing to do with firmware. This is in your Linux user space. So we try to target the big hyperscale, millions of drives or thousands of drives in a deployment environment. We talk about this one, we call it health chain management. At the same time, we wish this library can also do some other drive storage configurations or optimizations as well down the road. Of course, we don't want to limit this one to one device, one type of device, right? So we see, hopefully we can do HDD, we also can do SSD and other storage devices. So how we lay out this, this project, basically there are two major parts, right? So the first top part, we call it health chain data collection. So this is the drive's lifespan, right? So from the vendor factory, we have lots of data from the vendor side. Then we have system integrator. They will have lots of data as well during the installation and integration. And at the same time, when the device is running in the data center environment, all the hosts will collect tons of operation data, right? At the very end, we see the device finally reaches the end of the life. We'll retire them. So we call this the health chain data collection. This is more data format uniform. So basically, if all the vendors can come up with a similar platform, we say format, so our consumers can quickly collect them and put them into one database to create a device lifespan library. The bottom part is the one we will focus on today. This is more software development. This is a health chain management API. So the reason we develop API is we want to provide our hosts a collection of tools. Basically, every environment use case is different, right? So instead of we build you a tool, we like to give you a collection of tools so you can build your own customized workflow to suit for your needs. So on the bottom, so this is the functions we have already implemented in the phase 1 development. You can see basically we can check device's health condition, whether it's good or bad. Also, we can let the drive do self-test. We can try to do non-data destructive field repair. And then, of course, decommission the devices based upon the devices, type of devices. You can do different ways to decommission those devices. This is the top level structure. Well, I'm not intending to let you read this page. Just this is a example of functions we have done in phase 1 development. So Seagate, we are in the process to go through legal and management to publish this library, the binary with the interface specification into our OCP GitHub. Well, so I will hand the floor to Naman to talk about the use case in the hyperscale environment.
So thank you, June, and thank you, Seagate, for putting this API, bringing it to OCP. Thank you, Stephen, for finishing my talk. So basically, the bottom line, just to reiterate, I guess, what Stephen said, I'll say it slowly and clearly. It's really about, from the data center point of view, in a heterogeneous environment where we have HDDs, we have flash, we have SAS, SATA, NVMe. How do we, in a unified way, bring diagnostic tools and deploy them? So all the vendors have tools, and with all the consolidation, now we have vendors with multiple tools. So getting these out there in a production system where there are problems happening is a bit of a pain. So this approach helps us unify these vendor tools, but now they're in a library format with a homegrown application invoking the libraries through this API, and we can deploy it all over the place. So when there's a faulty device, we can invoke the right library. Our previous methods were, collect logs, send them for failure analysis, and this model really doesn't apply in a hyperscale setup. We don't have the time. So basically, when in doubt, the device has failed. And failing a good device is costly. I mean, maybe not the cost of the device itself, but the fact that the machine is down, somebody has to go replace the device, all of the break fix. So the approach here is for the vendors to provide their tool sets as this library, which would be able to collect logs if required, but most importantly, have this health check function. Gives a yay or a nay in real-time diagnosis of what's going on with the device. And they get to spit out an error code, which we would pass back to the vendor to help them understand why the devices are failing. So this is a vendor-specific error code. The secret sauce is in their library, so that they don't have to share that. But they would be opening the library or providing it to different customers, and then it can be wrapped in a tool. I know, or I anticipate, a whole bunch of false positives and false negatives at the start of this process. But the idea is that if more customers provide this information back to the vendors, they can fine-tune it and update the libraries with better algorithms, which is, again, easier to deploy than fixing it in dry firmwares and pushing out dry firmware updates in production. And like Stephen mentioned, it removes from the hyperscale customer's point of view, or any customer's point of view, parsing all the smart data, parsing the various logs that the drive may have to actually determine what's going on with the device. So that's really how we plan to approach this, and trying to make my job, I guess, easier, because I am tired after 10 years of trying to look at smart data and determine what device is problematic or not. So June has already covered some of the initial functions that the first version of the API have. The idea for future, a couple of them would be, one is security. How do we securely deploy this vendor library? Because it's vendor code, so that's a problem that needs to be solved. We know customers are going to be requesting things or want to take this already, or input I've got from other people is some sort of real-time monitoring, prediction of drive failures. Today, the model is not designed for that. It's designed to actually diagnose a device that you think has a problem. It has soft errors, not necessarily hard errors. That part is easy. But the library itself is not probably going to be able to do it. It'll be able to collect the right hooks per device and then feed that into some analytical engine where, again, we'll probably need more vendor logic to be able to make a determination at a fleet level to decide which devices are possibly going to be failing soon. So call to action. Jen?
Yeah, can we go back to the previous slides? So we want to talk a little bit more about the future and what we do here, right? So phase one, we are just taking a snapshot of your current drive condition and try to make the intelligent decision for the host, right? So phase two, we are trying to do more proactive work in there. So everything happens in the in-situ situation, right? So phase two, hopefully, depends on the host size stomach. So we probably can do data destructive drive fix repair as well. Like just in the previous session, Microsoft talked about a few depop, right? So for Microsoft, they can write their own drive software to do to work with Seagate, right? To get the depop done. But if you don't want to write your own depop function, so probably you can go to the library. The library will have the depop feature in there, so you can the library will tell you which head is going south, right? So you need to kick it out of your capacity and keep using the remaining disks and heads. That's the phase 2. Phase 3, we think hopefully, not for everybody, but for some use cases, we put the engine on each server and we can actively, in real time, monitoring your stored device health condition and then eventually give you we should say, real-time decision to tell you what you need to do with your storage devices. All right.
So, call to action. 1, we would like vendors to support this effort by providing libraries. And we actually already have a bunch of vendors who've signed up. Seagate, obviously, Intel, WD, Micron, Toshiba. They're all working on this, or they totally like this idea. Feedback, definitely, or what else can be added, what's new, or what would people like to see. Software developers to help create maybe a generic wrapper to be able to invoke this, but I'm sure at least the larger customers would probably have their own homegrown apps because then they can add their workflow into it. So do we have the slide on? Okay. As we have time, I can go a little bit into the API itself. Each function in the API is essentially task-based. So the application can kick off multiple tasks in parallel on multiple devices if required. It's non-blocking. And then check back to see if the task is completed. The API itself is designed to be forward and backward compatible, which means that nobody really is going to step on each other's toes depending on what gets added, who is using what rev of the API, whether it's the application or a library, and compiling with, say, a newer library or newer application working with older libraries. So nobody has to all check in at the same time, none of that stuff. That's really the key thing there. So it's set up to be very collaborative. People can go off their own ways as long as they don't completely break the API. They can do all sorts of proprietary stuff. But the idea is that everybody gets to be able to diagnose devices in production in a common way. Questions?
So you mentioned in the future that you'd be doing stuff real time. Do you imagine for hard drives that this was not disruptive to the I/O flow, as log pages are a little bit now?
So the way we envision this tool to be used, typically it's not going to be while that particular device in the system is online. The system will be online, but maybe the application has decided there's some problem here. So that particular device may be taken out of the online application at that point. Now, the API provides online and offline functions, which essentially mean online, there should be no real I/O timeouts while the library accesses the device. Offline, it could do a captive operation like, say the reman that June was talking about. And it could take, many hours to complete, or some kind of field recovery. So the idea is you invoke based on your use case.
Okay, thank you.
Hi, June. It's Bill Carter. Really interesting API, and you've applied it to hard drives and storage. It seems to me that this is, it's also applicable to other devices in the cloud.
So let me take that quickly. I know June comes from an HDD background, and Stephen's first pain point was HDDs. This applies across Flash as well. And a lot of the other vendors who are working on libraries or support this are working on it for Flash.
Well, I'm going to take it one step further. So in network appliances, all the layer 1 devices, that connectivity, particularly optics and optical modules, and their firmware's in there, and we have monitoring firmware, but we're not collecting that, storing it, and acting on it. Memory, same thing. Internal to compute, you have certain health checks that are going on internally on bus speeds and correctable errors, a QPI bus and other things. I mean, fundamentally, you're creating a framework that you can apply to a lot of different hardware failures. And it seems to me like well, first off, can it be applied to those other things?
Yeah, so that's a very, very good point. Actually, Seagate, we are actively talking to different vendors as well, see whether we can work together. Basically, API is just a software implementation handshaking approach, right? So we can use this handshaking approach to apply on all devices, not just storage, network, and also memory as well. So we are actually talking to different vendors to see how we can work together. So in the in this group, if you think this approach will apply to your daily work, let's talk as well. See how we can make this set of API rich and capable.
Yeah, and I'm thinking one step ahead where now let's go look at this, who's going to write the software to do the AI work on that
Look
data
at it,
set.
Mike.
And I think if we had potentially a data set that spans more devices, that we'd probably have, a lot more interest. So
Yeah.
we can explore that as well. It's a great idea, thanks.
We need to get together under George's storage project team. So yeah, to talk more about how we can work together as vendor and the host. Yeah.
Yeah, you mentioned making contribution and joining in the API discussion, but yeah, there's no place anywhere where that's available or people can look and join, other than through, vendor interactions that are out of hand. So
for right now,
we need to get it on
yeah.
the project webpage and a work stream going, and then I think more folks will join. We have time for one more quick question, or two really quick ones.
My question is going to be quick, but the answer might be long. So this is a software running on the host. To talk to a drive, there's a lot of things to cross to get to the drive. There's the kernel, C library kernel, the HBA. This is a place of fun. So how do you differentiate problems that happen along that path as opposed to problem on the drive? And other point is, when you get really a drive in bad shape, it goes away.
Right.
How do you talk to it?
So this is not designed for hard errors, like I said. This is soft errors.
Even soft errors,
Right.
this kernel is going to kick out your drive.
Well, if the drive is gone, then it depends on the architecture. Some hyperscalers have reset and power cycle capability, which is the first step you do anyway outside of this whole tool. So to see if the drive comes back. If it doesn't come back, there's nothing else you do at that point. As long as you're within the AFR rate, typically at scale, you don't really care so much. The idea is that you still are wanting to see if the drive is good, then keep it going. So you give it one shot. Regarding whether it's an HBA versus the drive, that is a little bit outside the scope of this particular API and project, because we are invoking the drive vendors, device vendors libraries to go and diagnose their tool, their device. But you go through the HBA, that's right.
Right,
And
in
so,
we support pass-through
So
command.
you guys are gonna, we're kind of out of time. The next speaker is Eric Chang.
thanks a lot.
Here. While he's setting up, there was one more quick question.
Sure.
Yeah.
Last quick question. Okay. So June just mentioned you have to train like a machine learning model to make a good decision on drive health. So I'm wondering what kind of data do you need and how frequent do you need that kind of data to train the model?
That's really a future thing that I think June was talking about. Like what Stephen mentioned was, in the secret sauce of the library, the device vendors should already have some of those hooks built in. So they can, if they see different things in the device, then they can make a decision based on that, based on their prior experience.
Okay.
Okay, the future aspect is, at fleet level, how do we predict that the fleet is aging?
I think there are some concerns about the exchanging the information between the data in the fleet and the vendors.
Well, there is no information going to the vendor here. It's all within the box. Their library is running on your production system.
Oh, okay.
Right. That is very critical because a lot of hyperscalers will not allow that.
Right, yes. All right.
Yeah,
Thank
Yang,
you.
we have some machine learning projects ongoing, so we can talk more, see how often we sample data. Yeah.
Sounds good.
All right.
Thank you.
Thank you, everybody.